Hey Sean, good to see you.
Good to see you as well.
So it was only a couple of weeks ago that you were in Sydney, Australia, speaking at the data engineering meetup there at Atlassian.
Yeah.
That was a lot of fun. But for folks that don't know you, tell us a bit more about who is Sean Falconer.
I'm Sean. I run marketing and developer relations at a company called Skyflow.
Yeah, awesome. And so what is Skyflow?
Well, so Skyflow is a data privacy vault for sensitive customer data. So essentially, you can think of us like a shared service model, the same way you might use an identity provider for essentially shared service across all your services in terms of who your customer is. Essentially, we're that similar model, but essentially for PII management. So how do I essentially isolate, protect, and govern access to sensitive customer data holistically across my entire stack?
Yeah, awesome. So, and obviously we're at the Snowflake Summit, so I guess Skyflow integrates quite nicely with Snowflake?
Yeah, I mean, we're platform agnostic, but of course Snowflake is a very big data platform, and we are partners with Snowflake, and they've been a great partner for us. So we have a lot of customers that use us in combination with Snowflake as well. So how can we add essentially an additional layer of protection from a privacy and security perspective on top of what we might already be doing in Snowflake?
Yeah, so I mean, getting into the nitty gritty, I guess, I think we were talking about this a couple of weeks ago. Skyflow, effectively, it's like, you know, perhaps it's got like your customer store or your user store, and it allows you to sort of, when you're storing that data in, say, Snowflake or other systems, have like some sort of hashed or tokenized value in those sorts of places, as opposed to having bits of PII sort of spread across all of your data stores within your business.
Yeah, exactly. You can think of it as a way to essentially take sensitive data. So this is essentially like the representation of your customer or your user. Like you might have a users table that you put in a data store today where you have a bunch of raw representation of that customer. But instead of that, you're essentially using Skyflow to transform the sensitive data into a non-sensitive representation. And we can do that using something we call polymorphic data encryption and tokenization to create data that represents the original sources but has no sort of mathematical connection to the original data.
Gotcha,
that preserves analytics, AI, whatever kind of workflows that you'd want to do with the data without exposing the raw materials.
Awesome. So what are some of the companies that I guess have inspired, I guess, this particular use case?
Yeah, that's a great question. So there's been a number of companies in like leading technology companies, so companies like Google, Netflix, Apple, a handful of others that also sort of pioneered this idea of a zero trust data privacy vault. And the idea there was that they recognized that the same way like secrets or encryption keys are kind of like a special class of data, they recognize that PII is also a special class of data, and they wanted to create technology specifically designed for handling that data appropriately. So they took their customer data and they essentially moved it into these, or isolated and protected it within these data privacy vault architectures, and that essentially remove the responsibility from their various downstream services. Because the challenge that most companies run into is they have a warehouse, they maybe have a data lake, they have their transactional databases, and they have all the kind of like SaaS systems, and all these things essentially depend on customer data. And you have to independently try to lock down and control access across all those different systems. So you end up with copies of this information everywhere, like thousands of copies that you have to try to police access to. So what we're trying to do is, how do you solve that essentially by taking sort of a first principles approach to solving the problem and creating this shared service model so that I have like one single source of truth that I can go back to control access across all these different systems while also preserving essentially the original integrity and usability of those systems.
Yeah, and I guess in a sense, like the whole purpose is to reduce the attack surface, right? So you don't have customer data that's, you know, strewn across the enterprise and things like that. You've got just this single place where, you know, a potential attack could occur. And so from, I guess, the maintainability, it's just it helps data engineers sleep better at night, right?
Yeah, exactly. I mean, a lot of it's about reducing the attack surface area and also transforming the nature of the problem to begin with. So if, like, we're at Snowflake Summit right now, we're in this, you know, big like hall where there's lots of foot traffic. If I had like thousands of diamonds and I threw them out on the floor, and then I tried to protect all those places, that's very difficult because, you know, I could lose track of where they are. And then even if I found them all, then I need to, what am I going to have, a separate security guard for every single, you know, diamond? they need bathroom breaks, they need to sleep, so then I need essentially backups of those people. And that's what we've done with data. But if I change the nature of the problem and I took all those diamonds and I put them in a secure locker, I could build as much fencing around that locker as I wanted, and it simplifies the problem, and I don't have essentially all this foot traffic that I'm policing against.
Yeah.
And you can do the same thing with data if you think about it the right way.
Yeah, no, that sounds like a really awesome analogy. I liked your talk on the diamond and cheese problem. That was really cool. So, well, thanks so much for chatting with us, Sean. Thanks so much for breaking down the data privacy problem that Skyflow solves. Really awesome.
Yeah, thanks for having me.
Thanks, Sean. Cheers.
Cheers.